Okay, I see that maybe we can start, Massimo, now.
Okay, thank you, Andrea, and good morning again to everyone, and thank you for your participation in this GM International webinar dedicated to safety relay and their application. Hello and welcome to also my colleague Andrea Spolo, Andrea, who will help me to lead this webinar. Well, today's topic intends to provide general overview into the world of SIL certified safety relay, always widely used in the process automation application. A little explanation on how our meeting will take place today. Our webinar will be mainly divided into two parts. A first part dedicated to a short presentation where Andrea will introduce the main concept related to the safety relay and their application. The second part will be left free for your question on the topic, in which Andrea and I will try to give an answer. Please don't use the chat for your question, but use question and answer function. Before starting with our presentation, let me introduce in short myself and my colleague. I'm Massimo Pagani, Product Manager and Technical Support at GM International. I've been employed at GM International for about 8 years, and my main role is to receive and process customers' technical requests or assist them in the correct choice of products to be used in their application. Furthermore, I collaborate with our research and development department for the implementation of new devices to be put on the market, and with the sales and marketing offices to promote GM products worldwide. As already mentioned, I have a pleasure to having with me today Mr. Andrea Spolo, our Global Manager Account. Andrea has over 20 years of experience in the machine and automation market. He has great expertise in international relations in the automation sector and has consolidated his experience in Europe. Now he takes care of customers and markets worldwide. So before Andrea starts with his presentation, I would like to present my company. GM International was born from the experience of Elcon Instruments, and for over 25 years design, engineers, and produce a complete range of SIL certified intrinsic safety devices. Our products are used in automation packages such as DCS, ESD, fire and gas, marine, and so on, in several industrial sectors as oil and gas, petrochemical, pharmaceutical, food and beverage, and railway. The next slide shows the complete range of our products. Here we can see intrinsically safe barriers, safety relay, which we will present shortly, isolator, multiplexer, seal-free power supply, termination boards dedicated to the most popular PLC DCS system, ARC multiplexer, and so on. In addition, our company promotes advanced course of functional safety conducted by an expert trainer such as Tino Van de Capelle. You can find all the information about it on our website. The goal of our company is to provide and guarantee innovative and high-quality products. All our products are tested one by one and must comply with the strictest work specification. Our products are ethics and seal-free systematic capabilities certified by third parties. Furthermore, over 15% of GM employees are engaged in research and development of new technologies. Many of our resources are reinvested in the research and development department. And last but not least, all our products are covered by a 5-year warranty. GM International has always been perceptive to market demand. For this reason, its products are innovative, in order to get maximum customer satisfaction. In order, the strong point on which GEM International bases its activity is the complete pre and post-sale assistance, in order to lead its customer to find the best solution for their application and to assist them in the correct use of the product. In addition, all our products are interiorly designed and produced in our headquarters in Italy and are tested in a highly automated process. The following slides show how GM International is located around the world, with over 200 people who make up our staff distributed on all continents. We have products stocks distributed in our main branches in Dubai, India, Singapore, Houston, and from this year also in Moscow. The last slide lists some of our main collaborators and customers distributed among system vendor, EPC, O&M, and end user. Well, now I'm leaving Andrea time for his presentation on topic today. Please, Andrea.
Thank you, Massimo. Thank you, everybody. So, as Massimo said, we divided this presentation in two. So this one is the first one dedicated to the technology, and then we have a question and answer that we received from you during your registration. And let's start from this slide that show where the safety relays can be used, where it's integrated, and why is integrated this way. So, you know, PFD, that stands for probability of failure on demand, indicates a real possibility that a device is not able to carry out a specific safety function. So, and of course, this is really has an influence on your seal for the loop, for your system, and so on. So on this slide show that we have from the sensing element to the actuator, and all the, let's say, layer or the parts in this system must have a PFD layer value, so and have a real influence into the seal loop, seal value for the loop. So for every product that, as I told you, that would be produced in the clear, stated by a certificate in the manual supervised manufacturer. And we just have a short poll, so maybe if you can say, answer to this simple questions, so maybe we can have a better idea what kind of attendee we have today to this webinar. So if you're using standard relays, C relays with monitoring, and so on. I want to share also with you later on these results. So it's you also maybe can tell you about the market. So let's leave another few seconds for your answer. Okay, I think all of you already answered, so we can stop now. We can share the results with you. So basically, these are the results. Most of you use safety relay. That is, of course, the topic of today. So we can go to the next slide. So. So safety layer used for any critical application, related critical applications, and where you have, of course, there is the SIF, safety integrity function, that must, of course, conform to 8661-508. It is the standard in the in industries. That is, of course, this is the the norm for the manufacturer, why the users, like you, of course, has to follow the 161. Of course, where can you use a safety relay? We have to use safety relay. Typical cases are where the controller is not able to meet or fulfill the power requirement, volt or amps. So you wanted to amplify your output from the systems in order to drive a specific load. Or basically, of course, it can be when you need multiplication of contacts. So you wanted to drive more contacts or more loads, and you need drive this kind of load by simple or single contact. Or when you want to invert the function from the safety system, so you want start to close, you want to open contact. So there are different cases. Application for safety relays are not only in oil and gas. Of course, we're talking about mainly oil and gas, but there are a lot of industries where safety is very, very important. And basically, safety relay can stop or initiate a movement in a controlled, safe manner. Basically, it can be opening or closing valves or start-stop motors. Those are the most simple functions. Simple, but not means, of course, not safe. It's maybe very safe, but very simple process applications. And as I told, it's not all oil and gas. It can be any kind of application where a failure of a relay can cause serious accident for humans, environment, assets, or image. There are a lot of cases in the application parts. On the field side, of course, the connection is very simple. You have also PLCs output that is dividing a relay, so together with the power supply. The contact are activated by, as I said, PLC or DCS, safety PLC, or standard PLCs, of course. And the load is driven by the relay. Can be, as we told you, can be solenoid valves for fire gas or ESD applications. Can be some beacons, horns, other devices like say lamps, where you have those are very important to be for alarming, of course. BMS, burner management systems, or motors. That is also another applications. Massimo, see there is maybe a question, or you already answered to that?
No, one of our customers said that we have some audio problems, and your audio is disturbed.
Okay.
Try to adjust.
Okay. Let's hope for better connection.
Yes.
And so, as we say, the standard relay cannot be used in a SIF, of course, because there is not, for that standard relays, you can find anywhere in the market, there is not a PFD, there is not a real and SIF certification in place. And so SILA certified relays is a relay with a known and warranty ability to perform given safety function. So there is a really clear explanation that is able with a certain warranty a specific safety functions. So safety function is reach, it's let's say, aim to reach specific state on demand. So you want to open a certain valve or activate a certain fire extinguishing system at a wanted time. So when you want to open, that relay has to assure you your safety in the application. So most of the time is the load is normal energized, so you want to open in case of failure. So the energized safety, DTS. That is the most common application. But you can have also the opposite, where you want to, let's say, you are normally energized, you want to energize to safety. So close your load and energize your load in case of safety. Those are the applications. So we'll say ETS, you will find a lot of time ETS, or you will find DTS, de-energized to safety, energized to safety, or de-energized to safety. You can have also 4 different conditions. So normal energized coil, or normal energized load, either normal open or normal close contact, and also normal de-energized coil and normal de-energized load, with of course a normal energized relay, normal close relay. So there are different technology. In this simple, let's say, drawing you see on the right side of this slide, you can find all say, typology of system to the driller. Let's go to the next one, which is more maybe interesting for you. So in this case, I have, of course, the situation where my coil from the system, coil means from the system point of view, from the DCS or PLCs, which is normal energized. And the load in this case is normal energy. So the safe state means that I reach this situation where, of course, I open my load by de-energizing the coil. I can also have also the situation where my coil is a normal energy and the load is open. So the safe state will be reached by closing the contact on the load. This case, the lamp will be on. So So safe state means reaching this and just my coil and my load is de-energized. So the last one is this one, when I have a situation where my the coil is energized, open contacts, by energizing the coil, I reach the situation where the load is energized. That is, those are the, let's say, all the cases possible in the applications. And make some interesting application example for you. So we talked about normal energized application, where it is really the most common in the process applications. So load is normal energized because the coil is normal energized. In this case, I can reach a level essentially by just using one single relay. Okay, is enough. Essentially, level is reached by one single relay. And we are talking about non-energized application. Okay. So if I want to reach a CL3, I have to use, in this case, 2 relays in series. Okay. So those will be driven by 2 different coils, and the 2 relays, the contacts that are, say, driven the load are in series. This is the I can reach a CL3 certification by using 2 relays in series. If I make the, say, the other example by normal de-energized load, if I use just a single relay, I can reach just a CL1 certification. Okay. If I want to reach a SIL2, I have to use a second relay. But in this case, it's not connected in series, it's connected in parallel. So in this case, just one, of course, relays is enough to close and to power my load. If you want to reach a SIL3, I have to use 3 relays in parallel. So if you remember, for the SIL2, for the SIL3, for non-energized, I need 2 relays in series. But for a normal de-energized, SIL3 needs 3 relays in parallel. Those are simple examples how to connect your load for non-energized and for non-de-energized application. And we have talked about safety because safety is very important in function safety, because safety means you can save people, you can save your plant, you can say don't create any damage for the environment and so on. That's why it's very important for the people. But of course, we didn't talk about availability, and availability sometimes goes in the opposite direction than the safety. It's not, of course, in specific functional safety matters, but it's also very important because availability means that I can, let's say, grant that my plant is still working correctly without any unwanted leak. Okay. So in this case, if you remember, this was the architecture for non-energized for SIL3 application. So I see that it's very safe, but I can also see that one relays, if I'm, say, go out of order for any reason, open for any reasons, I have my plant is not working correctly, my load is off, even if I don't have any real emergency situation. Okay. So in this case, I say that I have very high safety, but low availability, because one relays is enough for, let's say, stop my plants. Okay. Also, in this configuration, if you remember correct, was the one correct for the SIL3 for normal de-energized applications. Also, one relay is enough for, say, powering my system. So it's not, in this case, I'm not in an emergency situation, but one relay is, for any reason, is closed the circuit and the load will be on. So in this case, I have also high safety, but low availability. So we're talking about safety and availability, but also a lot of times availability is a very, very, let's say, critical point, not related to the safety, but critical because maybe you stop your plant, you don't produce, and your chemical process is not working because you have a failure on your hardware applications. Okay. Let's give you another, say, more information. So let's talk about non-energized load with different architectures. So this one is the first one, 1 out of 1. With 1 out of 2, so with 2 relays in series, as it was necessary for SIL3. 2 out of 2, so 2 relays in parallel. That is not correct for non-energized, but it's also important to make sense. And the last one is a voting. So 2 relays are voting for the right function, for the right function you want to perform. So let's look about 1 out of 1 architecture. So here I have a probability of safe failure per year, probability of dangerous failures per year. Okay. Dangerous failure means, let's say, safety, of course, and safe failure means availability. Okay. So in this architecture, 1 out of 1 architecture, I have, let's say, mean time to failure for dangerous failure, which is 50 years. Okay. So dangerous failure is quite safe, and also safe failure, because one relays can fail with a certain probability. This is for 1 out of 1. If I'm using the 1 out of 2 architecture, I see that it was, if you remember correct, for normal energies, was necessary for reaching a CO3 certification. So I see that I improve a lot on the dangerous failures because of my mean time to failure has increased 50 times. So in this case, 2,500 years, so a lot of time, much more than the lifetime for hardware, of course. But I decrease, in this case, increase the dangerous failures, so improve, but I reduce by 2 times the safe failure. So it means that my system is more safe, but low available. So I can have much more, if you remember, one failure or one relay can stop my plant. Let's look at the architecture 2 out of 2, which is this one, which is not correct, of course, for the normal energized applications. Here I reduce a lot from a lot the dangerous and improve the safe. But of course, the system must be first safe and then second available. I cannot reduce my safe failure by increasing just with dangerous and just a safe failure. That is not the correct one. I would say that, of course, the voting system 2 out of 3 is the most correct, because I improve a lot of the dangerous failures and improve also my safe failure as well. In our system, you see later, we are adopting 2 out of 4 architecture, that in this case, those relays tolerate also 2 failures. Okay, I want to stop now with a new poll, if you can answer, because maybe it's also important for you. For us, have your opinion on this kind of relays. So what feature for safety relay is the most relevant? You can choose also the multiple choice poll. You choose more than one. I see that high availability for you is quite important. Okay, let's leave another few seconds for you for answering. Okay. Okay, I don't see any further votes, so I can stop now. I want to share with you the results. If you see, safety is very important, but also availability is quite important. Okay, thanks for voting. We can close this one and continue with the presentation. Okay, so we have talked about safety and availability, and we wanted to answer you and give you some tips about architecture that we decided to use in the GMI for the safety relays. That is architecture that is consisting 4 relays. Those are the 2 are in parallel, and in series with the load, and then parallel in the series with the two relays in parallel. So there are 4 relays inside that are working simultaneously. And by this slide, I can see how I can improve safety for normal energized application and for normal de-energized application as well. So if you look at this slide, you can see that one release is not sufficient for the dangerous failures. So I want to open, because the normal energized means I want to open my load. If one is stuck, is maybe have a problem where it's not open, this is not sufficient, because the circuit in this case will be opened by the 2 relays in the bottom part. Okay. So also for normal de-energized, it means I want to close my circuit and one relay remain open and remain open. And this is not enough because my circuit is closed by the other side of the circuit. So this kind of architecture improves a lot the safety for my system. And in this case, we say that each hardware fault tolerance is equal to 1. Okay. And it can be also equal to 2, of course, but let's say 1 is very, can save a low function. And the second one, maybe not, but if you are having the same side probably of the system, you can have a fault tolerance too. By the way, we talk about safety, but I see that this is important because I don't lose my availability. So for normal energized application, I see that I don't want to open, so I'm still in a safe condition. But one relay is opening by error, but my function is still open. So it's safe, but also available. So I don't lose my function for any reason. So also in this case, if one is closing, I don't want to close by my system didn't decide to close. So, but one is closing, the function and the load is still open. So this kind of architecture improve a lot safety and improve a lot also availability. So the last topic for today is why choosing a relay with built-in diagnostic. So there are relays with diagnostic and relay without diagnostic. So there are a lot of reasons to do that. Of course, it depends on what you wanted to acquire as information from your system. But basically, built-in diagnostic for the relays and are important because maybe old system, digital out, do not support the load diagnostic, so they're not able to collect information from the load. There are systems and systems. So in our experience, we have seen a lot of applications where the system do not support the load diagnostic. We said also that digital output, PLC digital output system, digital output are voltage and current limited. There are also reasons why the diagnostic have a lot of digital output diagnostic limits. Okay. And also why? Because smart relays or the diagnostic relay with diagnostic make the diagnostic available to the system by different interface systems. We will tell you maybe later about that. There is a specific also webinar on this topic, so if you want to check it. And also smart relay extended diagnostic capabilities. The last point is the real-time alert for any load fault, both for non-energized or non-de-energized. So most of the time, your system is not under control if you don't use a relay with diagnostic. If you use a relay with diagnostic, you can get in real time any kind of fault That can be short, open circuit, or power supply. Okay, we give you some tips on this relays, but maybe the last part of presentation webinar today is maybe also important for you because we can, let's say, answer to your question that you sent during your registration. If you have any question, please also you can write on queue.
Yes, we have a question.
Yeah.
Where our attendee asked, I have MCC interposing relay application where safety relay contact rating is 110 volt DC, 5 ampere. I couldn't find any safety relay for this contact rating. Is there any reference relay or still certified contactor available for 110 volt DC 5 ampere application? Well, we also said that for this kind of rating, surely we need a particular kind of relay, solid state relay, cover this kind of rating. In our portfolio, we have not this kind of relay for now, but probably we will have in a short time.
Yeah, indeed, 110 volt DC is a really complicated voltage. And
Yes.
of course, we can drive it, but it's only limited to few hundred milliamps, not 5 amps, not possible at the moment. But we are working on that, and we will release, as Massimo said, new product regarding this kind of load, because it's quite often required, not only. So there is another question. Please explain about line and load monitor, how it is implemented. We have a slide later on, so we'll just postpone this one. Nice presentation. Please share the presentation to our email. Okay.
That's a problem.
And we can also share with you, but it's not, of course. Basically, you can see our, let's say, this webinar is recorded, so you can have a look later on if you want. Please send us an email if you want to have this kind of presentation in a PDF format.
For the line and load diagnostic, we will have another webinar that explains the real application of the smart relay. Do you want to introduce it, Andrea?
Yeah, indeed. Yes, we have this kind of webinar. If you look at our calendar in the GMI International website, you can book your seat for that webinar. Yeah, we have some slides that explain a little bit how this kind of relay is working. So we have the question and answer. So if you want to start with that. So most of the time we have this kind of request, and also we got from you when you register yourself. So please, Massimo, can go.
Yes, a typical question that customer make it to us is if safety relay can we install in hazardous area? Yes, the answer is yes. It's possible to install a device such as a safety relay in a hazardous area, placing it in a special enclosure certified for the hazardous area installation. Or, as shown in the slide, in more cases, there are safety relays certified for installation in Zone 2. A typical example is GM International D5290S relay. This allows us to install the relay as close as possible to the load with great advantages in save cable. This means save cost. Another typical question regarding the pulse test compatibility. What is it? Almost all PLC DCS systems have the possibility through a series of pulses to test the status of the line that connects them to the relay coil. Compatibility with these pulse trains is very important in a safety relay. First of all, to allow the correct test of the line, and moreover, to avoid that these pulses causing the chattering effect in the relay, or to avoid the spurious activation or deactivation of the load, as well as damage of the safety relay itself. Another question is related to the multi-contact output. Is there any solution offering multi-contact output? The answer is yes. There are solutions that provide for multiple output contacts controlled by a single input. These multiple outputs allow us to have multiple loads connected and driven simultaneously. An example is the D5290S078. These allow us to drive at least 2 seal loads with only one relay. Well, other question regard the connection unipolar or bipolar. The safety relays can be connected in unipolar or bipolar configuration, as shown in the picture. A bipolar connection allows us to completely isolate the load, and this is recommended especially in application where the load must be powered with high voltage. From an electrical point of view, this type of connection gives us greater safety thanks to the complete isolation of the load. Unipolar connection isolates the load only on one of the power supply lines and allows us to bring a negative to earth in case of need. Furthermore, this type of connection allows us a great benefits from the point of view of cable savings. How choosing a relay, a safety relay? The choice of the correct safety relay must be made taking into consideration various factors, such as compatibility with PLC pulse test system, the type of coil power supply. We can say that we have different power supply coil. For example, 24 volts, 110 volt DC, or 240 volt AC. Important for the choose of the safety relay is the safety function. It's important to know and to choose the safety relay respect to the safety function that the relay have performed. We know that the typical safety function is normally energized or normally de-energized for a typically fire gas system. We can choose the relay with the line and load diagnostic. This kind of relay gives us the possibility to monitor open or short circuit of the load and the line. We give us information about power supply of the load, especially when the relay is in de-energized condition. This kind of relay gives us the possibility to monitor the earth leakage in respect to the load. And again, we can choose the safety relay about single or multiple contacts, and surely for the contact rating of the load. We have different relay with different contact rating, for example, 5 amperes or 10 amperes. Other question? Yes, Andrew.
Oh, yeah. I was just telling that a lot of say, simple things you have to know when you are designing a system where you want to use safety relays, and also from the past testing, from the function you want to perform, and so on. Sometimes, of course, you can incur in some problem if you don't check perfectly what you want to safety.
Yes, thank you, Andrea. Okay. The other question is, can the fault for a monitor the relay be mirrored directly to the PLC DO? Yes, there are relays that when they detect a fault in the field, can, through a variation of the dynamic impedance of its input, send a fault signal to the most modern supervised PLC DCS system. This function allows us to reflect information relating to the field fault directly to the supervised DO card of a PLC, both in the off-state through the pulse testing system and in the on-state by reading the static return of current. The DO card of a PLC system can detect the information relating to the field fault. This system, through an upward impedance variation of the relay input circuit, allows the supervised DO to see the fault in the field. This system allows considerable saving in engineering cost, as it allows us not to use a dedicated DE card for this purpose. And
this is a point, because in this case we are already talking about the monitoring relays with the monitoring system, and in this case you can have contact for fault. So, but your system has to foresee additional card for acquiring that fault by digital input. And or in some applications, in some DCS, you can mirror, you can read this fault through your digital app. It is a very, very interesting function you can use on our safety relays. Okay, so any question from Material? No, I don't see. So we can go.
The other question related to the Modbus. Can the fault be interfaced with the feed bus? There are a particular, yes, there are a particular safety relay models called smart relay, which can provide a complete diagnostic information through Modbus multi-drop RS485 protocol, if a Modbus master is available on the system side. Up to 127 modules can be arranged in a multi-drop network and monitored, configured by a single master unit, as shown in the following picture. Through an address, each slave contains a table of parameters. Each of them is univocally identified through an address, and when requested, make available its value for reading brightly. What are the advantages of using Modbus communication? With a single Modbus RS485 interface, it's possible to connect and communicate with all the relay present on the same bus. Multi-drop connection is possible and the communication can cover a distance of up to 1,200 meters. Another advantage is the possibility of not using a dedicated system to monitor alarms. This allows us to have a significant saving in terms of cost. And last, real-time information on the type of alarm and on the health of the load and the line. It's also possible to Modbus a complete remote programming of the relay. Well, Andrea, I leave you for the next question.
Yeah. Okay, so he got, maybe it was not from you, but in the past webinars, people asking, the C3 relay can be used in C2 application. So that for us is simple because we are working all the time with this kind of question, but it's not really, say, simple to understand, of course. Let's start from certain things that define the cell level. So they can be 1, 2, and 3, and 4 for the most mechanical, of course. And C relay can be used in each application, but not the other way around. So, of course, if C3 is most safe, more safe than C2, C3 can be used in 2 applications. If you look at these, okay, example, and I have maybe a seal C3 relays that is today C3, but when I started using, the seal level degrades in time. So after a certain year, I'm not anymore in the C3 areas, but I'm going to follow the blue line in the C2 and probably in the C1. So the device must be tested every certain period that is defined by the manufacturer. That is the most important thing. So if you test again your relays, or in this case, I can reveal all dangerous failures on my relays. I can test again, and I can start from practically from zero, and I can move again to C3 areas and have my system safe as well. So if you see is a graphic that is going up and down means that at a certain period to test again my hardware. Otherwise, I'm not anymore safe. But the important thing for the question was, can you use a seal relays in C2 application? The answer is yes, because I can, using higher level of seal than necessary, allow to reduce frequency of T-proof. Okay. If we need testing, this kind of test that have to perform my hardware to say, reveal or dangerous failure, and has a lower incidence total PFD average of the SIF. Example, if you look at the manual for our relays or safety manual, other safety apparatus you are using, it can be, of course, seal-free probably for 1 year, but if you're using the seal application, it can be for 10 years. So the lower seal I'm using for my application, higher T-proof time. And so I can extend my T-proof time. So basically, I can use my CO3 relays for a longer period without performing a test. So better hardware for lower performance required in that case. Hope we answered to this question because it was say, typical from our customers. So some relays aspect and what makes a safe relays, of course. You can use, of course, the base for achieving seal rating is to use architecture also. This is one possibility. Like the 2 out of 4 that we introduced in our release is a basic system to reach a certain safety. Okay. So the same architecture can be used not only on the, let's say, hardware, on the, let's say, outgoing part to the load, in this case, but also inside, I can use the same, also the components can be used in a redundant system in order to achieve certain level of seal. It's also important that maybe you heard about a data factor. Data factor is another factor to be considered because the data factor means that the same hardware from the same producer, from the same manufacturer, from the same batch can fail probably at the same time. So using the same hardware for, say, for redundancy can reduce or increase, of course, the safety, but can be reduced a lot instead of using 2 different products or 2 different components. So the architect, of course, affects the safety and of course, also the availability in different way, as we have seen. For example, architecture 2 out of 2 for normal Energized is not, of course, that. Okay, so what makes us relay? So, of course, we are talking about safe components, safe product means safe components, better results. For instance, relays inside the single relays inside is, of course, we are using gold plating, silver relay, and multiple contacts. So there are a lot of aspects that improve the results on the safety relays that we are using, of course, on our hardware. Of course, and also it's very important have the FMEDA analysis. So every single component inside the relays is available. That means SMED components for the card is available with a certain FMEDA analysis. And this is supplied by the component manufacturers to us. As we are, say, making available for our customer and safety manual with all the, say, the familiar complete with measures failure, the safe failure, and so on, and TDF. Also, the components inside the safety lake, for every single component, there is a real, let's say, FMEDA analysis with all kind of failure, not, say, safe and dangerous. So single safe relay is not like standard relays. from all these kind of aspects we have shown you. Another question was why gold-plated contacts are important. So maybe Massimo, you can answer to this question because you are, say, you are having from different customers.
Yes, gold plate contacts are very important, especially in application where are involved low current, about typically lower than 100 milliampere. This is because with the low current, we can incur in some problem related to the oxide of the contact. And with a gold plate contact, we can avoid this typical problem related to the low current.
So gold plate relays was also important both for safe and say dangerous failures.
Yes, more of our relay are gold plated contact and allow to work with current lower than 10 milliamp, especially in digital input application.
Okay, thank you, Massimo. So coil voltage and the relay load currents. So there are different aspects. So coil can be 24 volt, 48 volt DC. We have also 48 volt DC. Under 10 VDC, we have seen that one attendee was asking for that. Under 15 VAC, 230 VAC. And here, the architecture, you can have normal open contact, normal close, single, or multiple, normal open, or normal close. So there are different architectures for different applications. In this case, the last two, we want to multiply the contacts, that is typical. So one contact drive more loads. And the relays, power, the loader relays can be with this 35 or that basically are not available in the PLC card. Another thing is we have talked about relay with diagnostic, the relay that can transfer or report any kind of failure to the system. And so we are talking about SIF relays with the diagnostic. Basically, it's very difficult because it's the software base, of course, diagnostic is the SIF2. How is it possible? Is it possible because here the red function is the safety function, so where my system digital output, which is driving the relay and the load. It is the safety function certified for safety. The orange or the yellow is the diagnostic, which can be with additional digital output, it can be with the Modbus slave interface, and so on. There are different possibilities. But these diagnostic functions and the critical function are not interfering. So the diagnostic is really not interfering with the safety function. In case of failure for the diagnostic, the safety function is still working correctly. And that's why the hardware can be realized in this way.
For this kind of relay, we can say that two different safety functions coexist inside the smart relay. The first one, that also the main function, consists in the input to output or coil to contact activation, deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. The second one is the diagnostics function. It provides full measure, voltage, current, resistance, or earth leakage of the load, also through Modbus protocol, and it can activate, deactivate through fault dry contacts, typically.
Okay, thank you, Massimo. Let's go to the, I think is the last one, differences between process and the machine safety relays. We are having a lot of times under requests from different customers. I would say it's a completely another world. Unfortunately for us, we cannot sell the product for machine safety. Why? Because the process application requires safety integrity level seal certification. Application is, as you have seen, from the last slides, from valves, horn lights, sound beacons. Most is valves, but there are a lot of course signalization systems that must be controlled. This is not a real manual control. It's not permitted. It's a one-to-one. So the system is driving, is activated coil, and automatically the output will be activated. No manual control is permitted. That is the most important information. While for machine application, the certification is a performance level, so it's a little bit different. It's also same, but there is a PLC market. Application are safety gates, barriers, light release speed. A lot of application in the machine or in the factories where there are safety control, or the red buttons, machine as you call it. That is one application. In this case, there is a real and manual control. And, because if you want to deactivate the alarm, you have to go there and let's say reset your system. So the applications are really different. Okay, so we finished here. I want to remind you the live webinars on our webpage. You can see much more webinars dedicated to different topics like Zener barriers, isolators, functional safety review, safety manual. We do have Massimo, another one, other two dedicated for safety power supplies, and also application for safety relays, real applications that I want to invite you if you have time. Anyhow, you can see this webinar that is recorded and will be available soon on our YouTube channel. I want to thank you with the last poll. If you want to answer, this is very quick. We take only 1 minute of your time. Thank you very much for your vote.
Thank you.
It's very good. Answer are very good for us. Thank you very much. I can stop now our pause, and I will remind you our names and our email address. You have our phone. Of course, you can phone and write us if you have any further question. Thank you very much again. Thank you, Massimo.
Thank you, Andrea. Thank you, our attendees.
And let's see soon on this kind of webinars. Have a good time.
Thank you. Bye-bye. You're a good time.
Thank you.